The universe is vast, mysterious, and teeming with enigmas that have baffled scientists for centuries. Among these cosmic puzzles is the super-Earth, a type of exoplanet that has captivated astronomers and stargazers alike. What secrets does this potentially habitable world hold? How can it help us understand our place in the cosmos? Today we will explore the 7 most unusual planets in the universe. HD 189733b, the Glass Rain Planet. Located about 63 light-years away in the constellation Vulpecula, is one of the most bizarre planets discovered. This gas giant, similar in size to Jupiter, has a striking deep blue color reminiscent of Earth's oceans. However, the similarities end there. HD 189733b atmosphere is incredibly hostile, with temperatures soaring to around 1,000 degrees Celsius, 1,832 degrees Fahrenheit. One of the most remarkable features of this planet is its weather. Winds blow at speeds of up to 8,700 kilometers per hour, 5,400 miles per hour, far beyond the strongest hurricanes on Earth. But what truly sets HD 189733b apart is its rain. Instead of water, this planet experiences glass rain. High in the atmosphere, silicate particles condense to form tiny shards of glass, which are then blown sideways by the extreme winds. This deadly glass rain not only contributes to the planet's brilliant blue hue, but also makes it one of the most inhospitable places ever discovered. The combination of searing heat, supersonic winds, and glass rain makes HD 189733b a fascinating yet terrifying world. Kepler 438b, the super-Earth. Located approximately 640 light-years away in the constellation Lyra, is a remarkable exoplanet often referred to as a super-Earth. This classification arises from its size, which is about 12% larger than Earth, and its rocky composition. Kepler 438b orbits its star in the habitable zone, where conditions could potentially support liquid water, a key ingredient for life as we know it. However, the planet's close proximity to its star, Kepler 438, poses significant challenges for habitability. Kepler 438 is a red dwarf star, which means it is cooler and less luminous than our Sun. Despite this, Kepler 438b orbits very closely to its star, completing an orbit in just 35 days. This close distance subjects the planet to intense stellar radiation and frequent solar flares, which can strip away the atmosphere and expose the surface to harsh radiation. While Kepler 438b potential to host liquid water makes it a prime candidate for studying extraterrestrial life, the environmental conditions resulting from its star's activity highlight the complexities of habitability beyond our solar system. The interplay between the planet's size, composition, and stellar environment continues to intrigue astronomers and astrobiologists alike. PSR B16-2026, B the Methuselah Planet. Often referred to as the Methuselah Planet, is one of the oldest known exoplanets, with an estimated age of around 13 billion years. Located in the globular cluster M4, about 12,400 light-years from Earth, this ancient planet orbits a pulsar white dwarf binary system. The pulsar, PSR B16-2026, is a rapidly rotating neutron star that emits beams of radiation, while the white dwarf is the remnants of a star that has exhausted its nuclear fuel. Methuselah's age suggests that it formed not long after the Big Bang, providing valuable insights into the early universe. The planet itself is a gas giant, roughly 2.5 times the mass of Jupiter. Its discovery challenged previous notions that planet formation primarily occurred in the relatively recent past. The unique environment around PSR B, the 16-2026b, includes the intense radiation from the pulsar, which would make the planet uninhabitable by Earth standards. Nonetheless, Methuselah's longevity and survival in such a harsh environment make it an extraordinary subject for studying planetary evolution and the history of the cosmos. Its existence suggests that planets can form and persist even in environments previously thought to be hostile to planet formation. 55 Cancri E, the Diamond Planet. Located about 40 light-years away in the constellation Cancer, is often called the Diamond Planet due to its carbon-rich composition. This super-Earth is about twice the size of Earth, but nearly 8 times more massive. Its proximity to its star, 55 Cancri, results in extreme surface temperatures, reaching up to 2,700 degrees Celsius, 4,892 degrees Fahrenheit. The planet's high density and unusual composition suggest that it contains a significant amount of carbon, which, under such intense pressure and heat, could form diamond. The idea of a planet with a diamond core has captivated scientists and the public alike. However, 55 Cancri E is not a hospitable place. The extreme heat and potential volcanic activity make it an unlikely candidate for life. Additionally, the planet is tidally locked, meaning one side constantly faces its star while the other remains in perpetual darkness. This creates a stark contrast between the blistering day side and the frigid night side. Despite its inhospitable conditions, 55 Cancri E provides a fascinating glimpse into the diversity of planetary compositions and the potential for exotic materials in the universe. Kepler 16b, the two-sun star. Welcome to Kepler. 16b, the planet with two suns. This planet has earned the nickname Tatooine in real life because of its astounding similarity to the Star Wars planet Tatooine. Kepler 16b is around the same size as Saturn and is just 245 light-years away from us. This was the first planet ever discovered in a circumbinary orbit, which is just a fancy way of saying it actually orbits two suns. This means that if you were to go outside on the planet, you would see two stars moving across the sky during the day. Can you imagine what a double sunset would look like? While it would be awesome if we could live there, this planet actually orbits outside the habitable zone, meaning it would be too cold for liquid water to exist on the surface. Gliese 4-36b, the burning ice planet. Located about 30 light-years away in the constellation Leo, presents a paradoxical combination of fire and ice. This Neptune-sized exoplanet is composed mainly of water, but not in a familiar form. Despite its high surface temperature, which reaches around 439 degrees Celsius, 822 degrees Fahrenheit, the planet is covered in hot ice. This unusual state occurs because the intense gravitational pressure forces water molecules into a solid form, even at high temperatures. The presence of this hot ice, also known as Ice 7, creates a bizarre and inhospitable environment. Gliese 4-36b orbits very close to its star, Gliese 4-36, completing an orbit in just over 2 days. This proximity contributes to the planet's extreme temperature and the formation of hot ice. The discovery of Gliese 4-36b has provided valuable insights into the behavior of water under extreme conditions and the diversity of planetary environments. The planet's unique characteristics challenge our understanding of planetary composition and the range of possible states for water beyond Earth. WASP-12b, the planet that's being consumed. Located about 870 light-years away in the constellation Auriga, is a gas giant that is being gradually consumed by its host star. This planet is extremely close to its star, orbiting at a distance of only about 2.1 million miles, 3.4 million kilometers, which is less than 1/20th the distance from Mercury to the Sun. This proximity results in a scorching surface temperature of about 2,500 degrees Celsius, 4,532 degrees Fahrenheit. The intense gravitational pull from the star is stretching WASP-12b into an elongated, egg-like shape. This gravitational interaction is also causing the planet to lose mass at a significant rate. Material from the planet's outer atmosphere is being pulled into the star, forming a visible stream of gas. Scientists estimate that WASP-12b could be completely consumed by its star in about 10 million years. This planet's dramatic fate provides a unique opportunity to study the interactions between close-in gas giants and their host stars. Observations of WASP-12b help astronomers understand the processes of planetary evaporation and the ultimate fate of such planets. The extreme conditions and dynamic interactions make WASP-12b one of the most unusual and intriguing exoplanets known. That's it for this video.